Okay, chemistry, this is for pre-AP and on-level thermo notes, part 7. So now we're starting to talk about specific heat. So what specific heat is the amount of energy required, the amount of heat required, because heat is a type of energy, to raise the temperature of 1 gram of a substance by 1 degree Celsius. So if I had 1 gram of anything, doesn't matter, 1 gram of carbon, 1 gram of oxygen, 1 gram of gold, 1 gram of whatever, it is the amount required to raise it 1 degree Celsius. So if it was at 0 degrees Celsius, just to get it to 1 degree Celsius, how much heat was needed? And so you might think that this is the same for all substances, but it's different because each substance is heated differently, and we have different activities that you can play around with that. There's a PhET lab that you can see if I put my gold ring and a beaker of water on the stove and I turn it on, they're getting the same amount of heat. One's gonna get hotter a lot faster. And so you can start to see that it's not the same. So they're gonna go up different degrees because they have different specific heat values. So specific heat, again, is a definition that we use to help measure the amount. So we have to have the same amount, the same mass of a substance, and we're raising it by the same temperature to figure out what its specific heat is. Once we do that, we can have lots of mass, so I could have tons of grams and figure it out. So people have already done this for you. And you're gonna learn how to plug in and either solve for specific heat or use the specific heat given to you to solve for other things. I don't expect you to know the specific heat of everything. Either you're gonna solve for it or I'm gonna tell you what it is. But the units for specific heat, if you go back all the way to the beginning of the notes where we talked about heat to begin with, if you see heat's in here, heat's units were joules. Specific heat is something different because again, it's talking about the heat required to raise 1 gram of a substance. So we have a little bit different units. We still have joules, which is the heat unit. So in this part, we're talking about heat. And then we have grams because we're also referencing mass, and we have degrees Celsius because that's the definition. If you think about that, all 3 of those things are in the definition. So all 3 of their units should be in the units for specific heat. Specific heat of water is going to be 4.184 joules per gram Celsius, so joules per gram Celsius. So it's important for you to know that one. That is in your notes. So if I give you a problem to work that has specific heat of water in it, I might not give you that value because I gave it to you in your notes right here. So maybe you should highlight, underline, star that spot so that way you can know where to find that information to go back to. That being said, I don't expect you to memorize that. It's not something that I'm like, oh, you need to know it, but it might be good to know where it's at in your notes to help you out. Specific heat, the instrument to solve for specific heat is called a calorimeter. And if we were still in class, we could do a coffee cup calorimetry lab, which you will be learning about in the other YouTube videos that we've posted on the lessons if you haven't already. In that, we are on the basis of the relationship between heat and specific heat and the temperature. So if we look at the equation in your notes, it has Q equals MC delta T. So Q is heat. If you forgot, go back and look at your notes where we talked about heat. It said Q beside it. M hasn't changed. M is mass. M was mass in our density problems. M's always gonna be mass. Lowercase m is mass. CP is what we just learned. It's specific heat. So this, and then last but not least, delta T, specific heat. Talking and writing is not my forte. Delta T, when you see a delta, that means it's changing. So this is change in temperature. So we always have a beginning temperature and a final temperature. So that's what all these things mean. So Q is heat, M is mass, CP is specific heat, and then delta T is the change in temperature. So we always have a change in temperature. We're gonna have an initial temperature and a final temperature. When we apply heat or take away heat, there's going to be a change in temperature. Just like if I put water on the stove and I figured out the temperature of it, and then I turned on some heat for a certain amount of time, and then I turned it off and I took the new temperature, there would be a change in temperature. If we're applying heat, it's gonna be some sort of change. So that being said, that's how this equation works and operates. So to find your change in temperature, all you're doing is taking your final temperature minus your initial temperature. So I'll write that one on here as well. So delta T is equal to TF minus TI. So final minus initial for your temperatures. That's the same thing that you're doing for any change in something. If you want to figure out your change, let's say you lose weight or you gain weight, you're going to take your final weight minus your initial weight to figure out your change in weight. And so same thing here, final temperature minus initial temperature. We'll talk about the rest of these equations on the next video because that's enough for this one and I want to let you digest it so we can start to understand specific heat.